Adding resistors, part 2. Let's see where the formulas come from. Here we have two resistors in series, R1 and R2. If they were in a circuit, there would be current going through each one, I1 and I2. The voltage drop across the first resistor from one side to the other would be V1 equals I1 times R1. The voltage drop across the second resistor from one side to the other would be V2 equals I2 times R2. Now the voltage drop from end to end would be the total voltage based on conservation of energy. The current times the equivalent resistance would be equal to the drop in voltage from one end to the other, which would be equal to the sum of the individual voltage drops across each resistor as written as I1 R1 plus I2 R2. Now you might notice that there's only one place for that current to go, so I1 has to be equal to I2, which is equal to the current through the entire system. And there we have the equivalent resistance formula for resistors in series. Here we have our two resistors in parallel, R1 and R2. If we put a voltage across these resistors, there would be a current flowing through them, such that I would be equal to I1 plus I2. From Ohm's law, we can replace the total current, where V is the voltage drop from one end to the other. And we can do the same with I1 and I2, where I1 is V1 over R1, and I2 is V2 over R2. Now you might notice that the voltage drop across each resistor is the same. And it's the same voltage drop from one end to the other because there's no loss in voltage along these wires. So these 3 points are all at the same voltage. These 3 points are all at the same voltage. So the voltage drop has to be the same across these resistors. That means V is equal to V1, which is equal to V2, and they cancel out, leaving us with our formula for adding resistors in parallel.